Okay, in this video I'm going to go a little bit faster because I'm going to assume that you have a good working knowledge. You worked through the Python example. You already have your data file in your directory and you know how to use Jupyter Notebook a little bit. So I'm going to go a little bit faster on this one because I think you'll see the parallels here. So now I'm going to start a new R notebook. So you just select R instead of the Python 3. So now it's waiting for R commands. You have your R kernel running. So the first thing I'm going to do is I'm going to read that data file in. I'll explain what we're going to do. So we're going to use various libraries here. I've used these over different analyses that I do. So I just like to have them all there in case I need to use them. So again, I'm going to cut and paste a lot. So this is a command. If you want to set a working directory, you can set your working directory, and then it can be different from your Jupyter Notebook directory. I found it a lot easier just to have everything in one place. So that's why I have that there. So we're in R now, and just like in Python, we created a data frame. In this case, I'm calling it data1. That's the data frame name. And then we had, in Python, it was something like the pandas read CSV command. Well, here it's read table, and then you're going to put in the CSV file name. We tell R that we have a comma delimiter, that's a separator, and that there is a header. The header has the variable names. So that's what that command does. And if we were to, and actually let me do this. So if we were to, I'm going to comment the rest of this stuff out so I can show you something here. So if we were to put this command back in. So if we were to put this command in, it's going to print, well, if we run it, it's got to load our packages up. This only happened the first time that you do it. So the output here is it's telling you it's a data frame, it's telling you how many observations there are, and it's showing you that you have a sub ID, which is an integer. And then we have, it identifies test as a factor with 2 levels, and it tells you what the 2 levels are. Item is a factor with 4 levels, tells you what those 4 levels are. It tells you proportion is a number, and those are the values, some sample values. And then RT is a number, and some of those sample values. So one of the issues is if we don't do anything here, it doesn't know what to do with the sub ID variable. And so what we have to do, the command up here, what we have to do is we have to tell R that sub ID is a variable, right? And eventually it's just a subject identification classification number. So here's the command. So that's the data frame. This is the variable name, and we're telling it as a factor, and we're keeping it in data frame 1. And so when I run this again, you'll notice the package stuff is gone. Now it's telling you it's a factor with 35 levels because there's 35 subjects in this. So now we're ready to actually do analyses. That's kind of important. If you don't have that, not a good thing. So one of the things we did in our previous example is we filtered the data a little bit using our Python commands. You can filter the data a little bit too. Remember, we dropped misses and false alarms out of our data set. So we can do the same thing here, and we can just type data2, and it will show us the data frame. So we're telling it to take data1, and we're filtering it by these things for the item, and everything else will be preserved. And we do that. There's our data frame, just like we had before in the Python example, right? So there's all of the people, right? And it's showing you, this is a nice output because it shows you that this is a factor, dependent variable, right? So we're in good shape. So I'm going to comment this out. And now what we can do with that data, now that we filtered, is we can do our analysis of variance. So here's how you do the analysis of variance in R. You're going to give it a name. It's just analysis of variance 3-way. I believe because that's what I was working through the example. So you can call it whatever you want to call it. So the AOV-EZ, this is a command. So this is in the command within the AFX package. So if you go into the AFX package, you can find the AOV-EZ command. So it's analysis of variance EZ is what it's called. We the first entry is the subject identification variable. Second entry is the dependent variable. We're telling it what data frame to analyze, and now we're telling it the design. So it's within subject's design with test and item as factors. If you do that and print it out, it'll be fine. But this nice command gives you a much better presentation in the table of the output. So we're going to do nice, and the AOV three-way is whatever the outcome of this analysis of variance is. And we have a couple of interesting important switches. So we can do effect size. The PES is partial eta squared. The correction factor, I do corrections on my analyses. Geyser greenhouse correction. You can also do Huntfeld correction. And then we could have it, if we wanted to, print the mean square error term. But I don't necessarily need that. So when we run that, we will get the analysis of variance table. So actually this table down here, because we're in Jupyter Notebook, will be replaced with our analysis of variance table. So if you do that, there you go. And so we have, if you recall, here's our test, degrees of freedom, there's your F value, P value, item, and it gives you, with this nice table, it gives you asterisks if it's significant, a plus if it's, borderline significant, with your p-values, your effect size, etc. Right? So that's kind of cool. The other thing that would be kind of cool is to see our means in a table. So this a-means command is going to do that for us. So it's going to take data 2, and it's going to group by our variables, test and item, and then it's going to summarize, and I'm creating a variable called mean proportion, or mean prop, and you actually calculate the mean of that variable. Now this is case sensitive. It has to match your whatever's in your data frame. Standard deviation, we're taking the standard deviation of that variable, and then it'll count up the number in that group to give you an n, and then we have to do the a-means, whatever you call this output, you have to do it here, otherwise it won't print. It will calculate it, but it just won't print, and I think that drove me crazy once because I forgot that you had to actually have a command to actually output it. So if we run this, we'll get our ANOVA, but we'll also get our proportions here. Mean proportion, standard deviation, and the number of observations in each one. So that's really cool, really easy to do. That's it, folks. That's your analysis of variance right there. Few commands. You just change a few switches. You can cut and paste, and that's all there is to it. You can save this notebook, and you can always go back to it. And I'll show you that at the end of this video after I show you a few tricks of what my notebook looks like. So here's another example. Let me bear with me another example of some things that we can do using R. So all of this stuff is the same at the top. Now what I'm doing here is I'm doing something new. I'm just just to show you how you can. You're not limited to the data set that you read in. You can do whatever you want to, just like you could do in SPSS with compute statements. You can do that here in R. And so one of the things I do is I give a prize to the person who does the best in our research study. And so what does the best mean? Well, it means have the most accurate responses and the fastest reaction time. So I just create a variable that sort of combines those two things, and then we would look for the person that had like the lowest variable. So what I'm going to do is create a new variable called prize in our data set, and what it's going to do is it's going to take the it's going to subtract off 1 from our proportion value. So the better you do, the fewer errors you have. So this will in effect give us the errors for each person. So if you got 80% correct, that means you had 20% errors, right? So 1 minus 0.8 is 0.2. And then we're going to add it to whatever the reaction time is. So we're just going to collapse across all the reaction times. And we would look for the person that had the fastest reaction time, fewest errors. That would give us our prize. So we're going to create this variable prize in the data frame 2. So that's the math that's involved with that. So data frame 3, what we're going to do is we're going to aggregate across this prize. Across this prize, and we're going to retain the sub-ID value. All the other values we don't care about. We're just sorting by the sub-ID, and we're doing this to data frame 2, and we're going to sum across those variables, right? Now what we want to do is, so that would create a new data frame, but now we want to sort it, and we want to have the lowest value at the top, so we know who to give the prize to. So DataFrame 4 is going to sort. So this order command will sort it. And you can see that I have down here, if you do minus data 3, it would do it in descending order, right? And then, of course, you have to print out DataFrame 4 in order to see the output. So this will create that new variable called prize, calculate it for everyone, and sort it for us. And if we run it, you'll see that sub ID number 136 had the lowest value, right? Out of all the people, that's the person who won the prize. So that's a pretty cool little trick that shows you several different functions within R that you could do. So the sky's the limit in terms of what you want to do in terms of your functions and things like that. Let me show you what it looks like, what a notebook looks like when you're sort of done. So this is a notebook for this set. So I have a markdown showing that I filtered guesses out of the data set, so that was important. I did that before the data file was even created, but the guesses were filtered out. This is the analysis of variance. This is what we did in the example. Then this is the prize, determining the prize, just like we did a second ago. Now, I also created an example because some of the analyses I did started with a different package I was using, created a CSV file in wide format, and I wanted to go from wide to long to do the analyses and sort and stuff like that. So if you're interested in that, here's some of the code that would sort of do that. You use sort of this gather command. I just sort of looked and found it until I eventually found R commands that did it, and then you had to play around with it. So if that interests you, I can send you this example or walk you through that example. But that's what that did. It filtered those data files and then did the analysis on it, right? And we had two different variables that I was analyzing, this thing called RO, which is a recollection measure, and familiarity measure. And so you can see I get the first one is the recollection measure. Here are the means, and then the second one is the analysis for the familiarity measure, and here are the means as well. So I did that starting with a wide format CSV file. So you don't even have to, you can filter it or change it within R if you want to. A lot of times I prefer to create the data files in long format because they're just easier to read, but sometimes you don't have that luxury. So that's the idea. So that's what it looks like when you have a notebook and the analyses are already done. They're here, and I can save it, and I can just open this notebook. I will go back and show you sort of what I've done. So this is the notebook for this study, and I have lots of analyses in here. Some of these you'll recognize because they're in the examples, but it goes on and you can do other sorts of analyses. So that's sort of what I have, sort of a static notebook. So when I'm writing things up, I can just open up this notebook, and it's so great to do that. So that's an example of doing some analyses in R. What I'm probably going to do is another video that does more complex analyses with ERP, but and I'll get that ready, but that won't be of interest to necessarily everybody. But this hopefully will get you started.